Hey physics friends, and welcome to 1.5, which is graphing. Today we're going to talk about how do we take data from someplace and then make sense of it. We're going to be using our Chromebook and Google Sheets to take two variables. You'll see I have an example here. I'd love to buy a boat, so I took the year that the boat was manufactured and how much that boat costs. Those two variables, and is there a relationship to them, and does that help you in any way? So to kind of get us started with graphing, I thought I would share with you just a problem that I've been having through the years. I would love to have a boat. And the problem is the boats that Mr. Hare likes, they're really expensive. Wakeboarding, wake surfing, water skiing boats, they're I mean, $90,000 for a boat that's at least 7 years old is pretty insane. And a new boat like that's in the hundreds, $120,000, $130,000 pretty easily. So how do you... Is that a legit buy? So what I did, I went to a bunch of different websites, and here are, the years of the boat, and these are how much these boats cost in thousands of dollars. And so then I graphed that data. So I pulled those numbers over here to show you that sometimes something like this, here's data, and you can kind of see a definite trend happening here, right? And the boats that you want to look for are anything below that line, because that means that it's something, it's good. It's for what year it is, it's below the average price. So you maybe want to look into it, like, is there something wrong with that boat? So you can pick out some of these data points, and you can find certain ones that are what we call, outliers, ones that don't fit the normal trend, that for the year that this boat was manufactured, and you're looking at all the different people selling them, this is actually a pretty good buy. So this is what we're talking about today. Taking a bunch of numbers, putting them in a graph to see if we can make sense and try to figure out what's going on to help us. So let's get started. When we graph, we're always on the x-axis over here. We're going to do this what's called the independent variable, the thing that we are controlling. And in my scenario that I just showed you, I was controlling the year. The thing that was varying was the price, and we call that the dependent variable. The price was what was depending. So we always put the thing that's depending on the y-axis, and the thing that we, the experimenter, can control is the independent variable. We always put that on the x-axis. Now when we graph, it's very helpful to put the x things on the left and then the y on the right. And usually when you make your t-tables in math class, x always goes on the left, y goes on the right. That's what we're going to do here to make our graphing pretty straightforward. We are going to be focusing on three different types relationships in graphing. There are many more, but we in high school physics are only going to deal with three. Maybe your data is what we call linear. It can be a positive trend, it can be a negative trend, but your data could be linear. Your data, and you saw this was the type of data that was here. This is definitely a quadratic. It's curving upwards. Or it could be leveling out and approaching some what's called an asymptote. So it could be approaching some line that it never quite reaches, and we call that an inverse relationship. Now, the shape of the line is called a line. The shape of this is called a parabola, and the shape of this is called a hyperbola. And the general forms you've seen from algebra: y equals mx plus b, and y equals ax squared plus bx plus c, and y equals a divided by x. These are the only three that we're going to do. Now, what I had for you is I have given you guys some data to manipulate, and there's some prompts over here to help you through to make sure that you kind of check all the boxes to make your stuff look very nice. So I'm going to walk you through how to manipulate data using your Chromebooks and where to click to make things look nice. So step one, it says put appropriate lines around the table. So what I'm going to do is I want to make a line underneath my titles. So I'm going to click over here on the borders. I'm going to make a bottom border. And do you see how there was a bottom line there? And now I'm going to make a line down the right-hand side. So I'll make a right-hand line like that. Format the width. I probably should have done that first. So I can grab in between and move this over so we can actually see what these are called. Or you can double click. If you double click, it will auto. But the problem is I've got this big long sentence, so that's not good. So I have to kind of manually adjust this one to make that work. So now I can see my data pretty nicely. Let's center my data in the cells. So I'm just going to grab all this data and I'm going to click right here, the horizontal align, and I'm going to put the center. And you'll see all my data is very nicely now aligned. And I've got it separated by lines. Make sure the data has the appropriate amount of zeros. You'll notice right here, this doesn't have a 0, and you may type in 16 and you type in 16.0 and it doesn't work. Like, it doesn't let you do 16.0. You have to go up here and give it the correct amount of zeros. So you can add zeros or you can subtract zeros. Or you can add zeros to the entire thing. You can grab all of them, add a couple zeros if you want to be more precise, take away some zeros so that they're all nice. Let's make a scatter plot. So in order for us to make a graph of all these things, I'm going to grab the title as well. So I'm going to come here, grab everything, titles included, because then it will help me put the axes titles in. I'm going to hit Insert, Chart, and it should just pop up with, here we go, a scatter plot for us. I can resize this to kind of make it fit inside my area. And here's my data. And look, it's already labeled it with spring length and mass, X and Y. All right, make this physical size the same. Okay, title each graph. My title isn't so good. I want the title to be length of a spring. So I'm going to copy this and I'm going to double click over here, paste it. So now I've titled it the correct title, number 7. Number 8, resize the title if it's too large. That looks pretty good. Title the X's and Y's, they've already auto done that, and if they didn't, I can go in and put that in. Display the line of best fit. So this looks linear to me. So what I'm going to do is I'm going to double click on my graph, and I can come over here to customize. And if I go and I click series, and I scroll down, and I want to show a trend line. So here's a trend line, and I can choose. I can choose linear. There's 6 of these different things. We are only going to use 3. And you remember back that we're only going to be linear, quadratic, or inverse. We're not going to be doing any of these other things because the math in them is a little bit crazy. So this is a linear relationship, so we're going to choose linear. If it was a quadratic, if it was like curving up, that's a polynomial of order 2. And if it was an inverse, you choose the power series. So don't do anything with logarithmic, don't touch it, don't touch the moving average, and don't touch the exponential. Those are the 3 we don't use. We use the first one, the third one, the fifth one, 1, 3, and 5. So linear. And then if you want to display it says display the line of best fit. So you have to scroll down in the label, use the equation, and here is my equation. It pops up. I also want to display the r-squared value. This r-squared value is important because it tells me how close the data fits. So this is an 87.4% match. The closer this number is to 1, the better it is. So display my r-squared value and then make sure my end results looks like mine in every detail. So here it is. These are all 13 things. I sped this part up, so I'm going through it pretty fast because you saw it the first part. So I don't want to take you through it again to just save a little bit of time. The other line doesn't quite fit it. We're going to choose the power. Remember, the first one, the third one, the fifth one. So we'll choose power there. That fits it much better. We're going to show the equation, display the r-squared value. Now, there's something very unique about this inverse that I want to talk to you about. So you'll see right now that my line of best fit is y equals 75.6 x to the negative 0.804. Round this number to 1, negative 1, because once it's negative 1, y equals 75.6 x to the negative 1 power. Now, that's the same as y equals 75.6 over x, like that. This is an inverse function. So this is the closest we can do using Google Sheets to give us an inverse function that's in the realm of the math that you're capable of at this point in time in your career. These exponents to a decimal, don't worry. I don't want. Some of you are able to do it. Some of you are in pre-calc, calc 1, calc 2, and you totally can handle it. But for my average and my expectations of you, when you do an inverse function, just round this to a -1. All right, we're going to do one more graph, and I'm not going to do this second one. What I'm going to do is I'm going to skip down, or the third one. I'm going to skip down to this one because I know it's going to be a quadratic, just so we can see that third type of graph and make sure that we cover them all. So let's make our graph. Now, here's where I'm going to choose, because you can see this curving up, I want to choose polynomial of order 2. So when you see your equation, I'm going to show use my equation. So you can see here it's ax squared plus bx plus c. Now if you could do a quintic, ax to the third plus bx squared plus cx plus d. You can do whatever you really honestly want to see which one models it the best. But for high school physics, we're just going to keep it simple. We're going to keep it with quadratic, we're going to keep it with linear, and we're going to keep it with inverse. So let's show our r-squared value, and that's a pretty good match, 99.3%, 0.993 matching. So there you've got it. Pretty simple to take some data, make it into a chart using Google Sheets, and then kind of start monitoring that. So you can crunch some real world data to see what's going on, what best applies to that. Now, we'll talk to you later, and good luck.